In primary hemostasis, also known as platelet plug formation, the clumping up of platelets is the first of two steps needed for hemostasis. Hemostasis is how the body prevents blood loss when you get a cut on your finger or somewhere else on your body. Primary hemostasis is divided into 5 steps: endothelial injury, exposure, adhesion, activation, and aggregation. Let's imagine that you cut your finger and the knife sliced through an artery. The first thing that happens is the endothelial cells will release PAF, and this will cause vasoconstriction to occur in the vessels. The first thing that occurs when the knife cuts your finger is endothelial injury, and a reflexive contraction of the smooth muscles near the injury site will be called a vascular spasm. The vascular spasm is what makes the vessel more narrow and reduces blood flow to it, and ultimately decreases the blood loss through the damaged artery so you don't bleed out. The second step is called exposure, and we call it exposure because the damage to the endothelial cells exposes the collagen that is below them. The damaged endothelial cells release a protein called von Willebrand's factor, and this binds to this exposed collagen. The third step is called adhesion. When endothelial cells are damaged, platelets come in contact with von Willebrand factor bound to collagen, and the platelets have a surface protein called GP1B that allows them to bind to the von Willebrand factor proteins. The fourth step is called activation. When platelets bind to von Willebrand factor V1 GP1B, the platelets get activated, which means that it does a few things. The first thing that happens to the platelet is that it changes its shape, and when it changes its shape, its membrane forms something like tentacles. Tentacle-like arms allow it to grab onto other platelets. The second thing that the platelets do is release some things. They release 6 things. The first thing is serotonin, then ADP, thromboxane A2, von Willebrand factor, calcium, and fibrinogen. The fifth and final step is called aggregation. Finally, when ADP and thromboxane A2 bind to platelets, they express a new surface protein called GP2B3A. Once GP2B3A is expressed on the surface of the platelets, they're now considered to be fully activated. GP2B3A proteins bind fibrinogen, which is a circulating blood protein that acts like a little pair of handcuffs that links two platelets together. Now each platelet has multiple GP2B3A receptors, so they can bind to multiple other platelets with fibrinogen. As a result, platelets on the collagen can attach to fibrinogen, and that same fibrinogen can be bound by platelets floating in the blood. This allows platelets to rapidly aggregate at the site of injury, and this aggregation is what forms the platelet plug that can help stop the bleeding. A platelet plug is formed from actin and myosin, and this stops the bleeding. You want to prevent further loss of blood from a damaged vessel, and here you can see that we formed a scab, and the scab has completely stopped the bleeding from occurring.